Hi everybody. We're going to get right down to introduction to trigonometry. Right away we need this word triangle because we are going to be doing trigonometry on triangles. Basics, there have to be 3 angles and 3 sides in every triangle. Small, medium, and large. So if I take a look at this one right away, this guy over here would be the small, and it's going to be opposite to the small side. And this guy over here is going to be the large one. And so that's going to be opposite to the large side. And the medium one, okay, is going to be opposite to the medium side. And generally, when we name these sides and angles, we use capital letters for the corners and lowercase for the side opposite to that actual angle. So we have this word opposite, okay, which is basically pointing away from a corner. The side opposite to capital E is little e. The side opposite to capital F is little f. But there's also 2 other sides that we could talk about, and they're called adjacent. The word adjacent refers to beside. So there are 2 angles that are adjacent to corner E, and the 2 adjacent sides form the angle E. All right, when we're doing this. So we want to direct our attention to right triangles. Now, right triangles, you know already, have a cool relationship in terms of the angle measures. There's a 90-degree corner here, and the 2 other angles must be equal to 90 degrees. Okay, when you add them up, they're both acute angles. And as far as the side lengths go, we know that when you square the 2 legs and add them together, it's equal to the third side, which we call the hypotenuse, squared. Okay, it's not a plus b equals c, it's a squared plus b squared equals c squared for that Pythagorean relationship. And sometimes the triangles are going to be turned, right, rotated, whatever, but you still locate the hypotenuse as opposite to the right angle. And so the 2 other angles, and again, it doesn't have to be A, B, and C. We could call these guys, let's say, capital M, capital N, and capital P. And so the hypotenuse would be little n, the other side would be little m, and this guy over here would be little p. All right? Notice, by the way, 90-degree corner, those 2 other angles are acute. If we did have an angle that was more than 90, then it couldn't have any other ones like that, and that would be an obtuse triangle, like we have up here. Okay, this triangle was obtuse because it had an obtuse angle, and the other one didn't have any obtuse or right angles in it. The largest angle was acute, so it's therefore an acute triangle. All right, moving along with our 90-degree corners, I wanted to mention that the Pythagorean theorem only tells us about sides. But trigonometry is a little more powerful. It's going to actually tell us about relationships on side measures and angles. So in trigonometry, we have 3 different special ratios called sine, cosine, and tangent. I don't know who came up with these names. There's probably some sort of Greek origin to it. But the important thing is that these represent ratios or fractions that we can form with the side lengths, okay, based on the angle that's going to be our point of reference. So let's take a look at this right away. I'm going to tell you the 3 formulas. The sine of an angle, and I'm going to take A as my point of reference, is going to be equal to the opposite of that angle divided by the hypotenuse. And the cosine of an angle, in this case angle A, is going to be the adjacent side to that angle divided by the hypotenuse. And remember, it's only going to have a hypotenuse because it's got a right triangle. The tangent is going to be the opposite of A divided by the adjacent to A. So let's see how this works out and why it matters. When I take A as my point of reference, it's pretty obvious, or should be pretty obvious, that the opposite is going to be the 5.7. And so when I'm calculating out the ratio of the length of the opposite is going to be 5.7 divided by the hypotenuse, which is side C, 10.3. Whoops. And as I said, this side here is the opposite. And when you work this out on the calculator, you're going to get a number, all right? And it's a really stupid number. It's always going to be a decimal amount, less than 1, when you do the sine or the cos. So 5.7 divided by 10.3 gives me approximately 0.553 going on. Now here's the thing about trigonometry. If you go into your calculator and you know that the measure of side angle or angle A is 34 degrees, you can type that into your calculator, sine, there's the SIN button of 34, and that tells you it's supposed to be about 0.559. Now, why is this not the same amount? Well, I measured my amounts, so there's not super accurate, but the sign that's in the calculator is calculated according to some pretty sophisticated math. Anyways, when I look at the cosine of A, I'm going to take the adjacent to A. Uh-oh, we have a problem. There are two sides that are adjacent to A, right? Remember how I said the angle, okay, the two sides forming that angle are called adjacent. But since the hypotenuse has already got its name, hypotenuse, then the letter B, the other side that's adjacent, is going to be called the adjacent because the other one's called the hypotenuse. So taking those amounts, I'm going to take 8.6 divided by 10.3 and calculate this out. Approximation again, because it's not going to work out evenly. 8.6 divided by 10.3 is 0.834. So, and it rounds up to a 5 when I type this into the calculator, the cosine of that same 34-degree angle, remember it's still my point of reference, right? My angle of reference is going to be cosine of 34, and that's about 0.829. Now I'm off by calculation, but these decimal values are so super accurate that the measurements I'm making are not clear enough. Now when I take a look at the tangent of A, this has an interesting side note. When you do the opposite of A, which is 5.7, divided by the adjacent of A, which is 8.6, this is actually the same way we calculated slope, right? Rise over run, which isn't just a coincidence, okay? It's something that we use when we want to measure the angle of a line rather than just the slope. Anyways, 5.7 divided by 8.6 is 0.6627, and so I'm going to round that up to 3. And then when I take the tangent of this 34-degree angle, it's in the calculator, is going to calculate that as 0.674. Approximate lengths again, 0.674. Anyways, the fact that we can do a relationship between these side lengths and the angle measure is going to allow us to work backwards to find missing sides or missing angles in different trigonometric triangle questions. So that's the intro. You're going to be doing a bunch of questions with these, and send me a note or put a comment in there if you have any requests on specific types of examples. Thanks, and have a good day.